In this video, we are going to look at our trig functions and also transforming our trig functions. So if we start moving it up or down, and if we start stretching it vertically, just to get a better understanding of what that looks like. So let's start out with our sine graph. Then we're going to look at our cos graph and our tan graph. There is our basic sine graph. So the sine graph with this equation, y is equal to sine x. That's it. Take note where it starts. It starts by 0, and then it increases. It turns by where x is 90 and y is 1. There's our turning point, and then it cuts, turns, cuts, and then the curve starts repeating itself, right? So that's why we say that the period for our basic sine graph is 360 degrees, because for the whole curve to complete itself before a second curve starts takes 360 degrees. So the period for this graph is 360 degrees. Okay, now let's start transforming this graph. Let's change to the coefficient in front, that value over there. Now, currently it's 1. If we call that the amplitude, right? So if we make that 2, we stretch the graph vertically. Notice, great teens, that it still starts in the same place and it still cuts in the same place. Maybe I must just take this away. So how it compares to the original is that it is just a stretch, but note that it still cuts and turns in the same places. So it still turns by 90 for x. However, the maximum value will now just be 2. And the same for our value over there. Our minimum value will now just be by -2. And that would be our amplitude. If we make it 3, our minimum and our maximum would now be by 3 and -3, but it still cuts and turns in the same place. What's going to happen if we make that negative? So let's go have a look. I'm going to put the basic graph back on there. Our y is equal to sine x. If we make that amplitude, or if we make that a value negative, let's make it -1. Do you see what happened over there? Instead of starting by increasing like our basic graph, it starts by decreasing. So all my values, where they were positive, where my y values were positive, they will now be negative. If I make my a -2, then it starts by decreasing, and my minimum will be by -2 and my maximum will be by 2. So without our basic, when you see something like that, you need to immediately be able to identify it and say, oh, my a value for this would have to be a negative because it starts by decreasing. Okay, let's take it back to a as 1. And now we're going to change to when we add to this. Some of you might use that as a Q value. It doesn't really matter what variable we use to represent that. It is shifting it up or down. So let's see what happens there. If I add 1 to it, the whole graph, as is, just moved up with one place. So notice, where it used to start at 0, now it is going to start at 1. And now my maximum would be by 2, and my minimum would be by 0. The whole graph moved up. Okay, what if we make it a negative? Let's say we make it -2. The whole graph moved down by -2. So -1, -2. It starts by -2 now, so it would be, you know what I mean when I say start. It's by 0 degrees. It is now by -2 instead of 1 where it used to be. Now, what about when we change to both of those? So let's say we go make a shift and we make our a value to, and we make our d or our q value, whatever you use, -1. Okay, now we have that, and you are just given that. And they say, find the equation for this. We have the equation on the screen, sure. But you're not going to have that in your test, unfortunately. So how would we go about figuring this out? Well, we could see immediately that it moved down because it's not by 0 anymore there, it's by -1. And also, if we can say like the middle of the graph, the middle of the graph is not the x-axis anymore, then we know that it must have moved up or down. Now we can see that it moved down because of that. But then we also have to figure out our a value. So how can we figure that out. You can say, if you can't see it easily, that there was a vertical stretch, you can take your maximum value, in this case 1, and you can subtract your minimum value. Your minimum value, there it is, -3. So we've got 1, and I minus -3. So that will become 1 plus 3, which would be 4, and then we divide that by 2. And then 4 divided by 2 will just give you 2, and that is our A value. So I'm just going to say that again. You take your maximum, you subtract your minimum, and then you divide that by 2. How can we also go about it, great dents? You can find the middle of the graph. The middle of the graph that cuts it in half. The distance from the middle of my graph to my maximum is 2 units. 1, 2. And from the middle of my graph to my minimum is 1, 2. So my A value must be 2, because that A value represents an amplitude, which is a distance, which is like the middle of the graph, the equilibrium of the graph to the maximum, which is 2, and then to the minimum, which is 2. So my A value must be 2. So however you decide to look at that, it's up to you, whatever works for you. Let's head over to the cos graph.